We can call these differential equations, or we can call them related relates, and we're going to talk about a cone question, a conical question. Sand. Sand is coming off a conveyor belt at the rate of 25 cubic metres a second and forming an inverted cone. So we're thinking sand's coming off and it's building up. So the sand is coming off a conveyor belt and piling as a big cone on the ground. It falls in a way that its height is always the same as its width. So even as it grows higher, it's going to grow wider as well, which sort of makes sense. We want to find the rate at which the height of the cone is increasing when the cone's 5 metres high. Okay. Let's go. I guess I could have left that there. That's height. And that's, we could call it width, but I don't really want to do that. I want to call that R. So if that's R, I'm going to go, that's 2R. So right away I've got a relationship between R and H. Get that out of the way. We have also got 25 cubic metres per second going on to the top of this thing here. So cubic metres, that's a volume. So we've got dV dt is 25. The rate of change of volume is it's increasing by 25 every second. That's a lot of sand. We need to find the rate at which the height's going up. So that's dH dt. So we're just looking for that chain rule pattern. So if I've got a dH dt, then what's missing? I need to have a dH on the bottom and I'm missing a dV on the top. So I need a dV dH. Well, luckily we've got this volume formula of a cone, 1/3 pi r squared h. Clearly we can't differentiate V because we've got an R and a H. We need to leave that H there because I need a dV dH. So I need to get rid of the R. So this is the job of that relationship over here. So R is H on 2. I'm going to square H. And I'm going to square 2. And I'm going to tidy that up. I said I was going to square 2 and then I didn't. Okay, so it's going to be pi on 12 h cubed, and I'm wanting this dV dH. So that's going to be pi on 4h squared. So pretty much, I know what that is, and I need to find that. So let's sub it in. I can lose that question now. Let's just go up. 25 equals, and then I've got a dH dt. That's what I want to know. And remember in the question, it said that I wanted to know height increasing when it's 5 metres high. So that means that height is 5. Sort of makes sense that this rate of dH dt depends on how big the cone is. If it's a massive cone, then 25 cubic metres per second isn't going to change the height too much. But if it's just a small cone on the ground, just starting, it's going to go up pretty quickly because 25 cubic metres per second is a lot of sand. Anyway, let's go. Let's get rid of that 4. That h was 5. 5 squared is 25. Divide by 25, then you're going to get, and then get rid of the pi. So dH dt is actually 4 on pi. I guess it's metres per, is it per second? Yep, that'll do, metres per second. There we go. That was a nice one. Good fun.